Well, in this video, we are going to talk about how to convert standard form, which is written in this way, ax squared plus bx plus c, in such a way that you have the exponents of the variable in the front and it goes all the way to the right, which is the constant here, that's the c term. We want to convert this form into vertex form. And the reason we like vertex form is because if you look at it, you can tell right away that the vertex is located at a specific coordinate, in this case hk. Whatever number goes into this spot for h and k, that's the location of the vertex. So in this video I'm going to show you how to convert from a standard form into a vertex form, and then I'm going to show you, for example, the nice thing about that is once you have it in vertex form, we can identify the vertex quickly. So like in this problem, if I were to ask what's the vertex, it's not immediately clear how to do that. All right, so the approach here that we're going to use is what's called completing the square. We've done this a number of times in the past. If you don't know what this is, please look at one of the other videos before you go on. Otherwise, let's continue. So the first thing I'll do is I'll move the 67 here to the left side of the equation. So y minus 67 is equal to 3x squared plus 30x. And remember, we cannot complete the square with a coefficient in front of the x squared term here. So we're going to divide everything by 3. So you have y minus 67 over 3, and that is equal to x squared plus 10x. Then what we're going to do next is add some mystery term here, right? And we're going to add it on this side as well. And we're going to set up these blank spots. So it's going to be completing the square, really means to make up some numbers to add in here so that when we factor it, we have a perfect square. And if you recall, the coefficient of the x term, 1/2 of that is what goes in here. And this number squared is what goes up here. So effectively what we're doing is we're artificially adding 25 to each side of the equation. And that's perfectly allowed. We can add whatever we want. We're adding 25 because it happens to be very convenient for us. And if you look at the right side of the equation here, when we factor x squared plus 10x plus 25, it's x plus 5 quantity squared. And then on the left side of the equation, we have some fractions and a whole number here. So in order to get everything to be the same fraction so we can combine them, I'm going to change 25 into 75 over 3. And another reason for that is because the denominator here is 3. So y minus 67 over 3. And we're almost done. So now what's left to be done? Well, all we're going to do is we're going to combine everything on the left side of the equation. So 75 minus 67 is 8. So that gives me plus 8 over 3 is equal to x plus 5 quantity squared. Now remember, we want to get it into vertex form when we have y by itself, and so that's effectively what we're doing here in the last couple of steps. It's just isolating y, getting y to be by itself. So multiply both sides by 3, and we get that 3 times x plus 5 quantity squared, and then subtract 8 from both sides. So y equals 3 times x plus 5 quantity squared minus 8. So we're subtracting 8 from both sides. So there you have it. Once you do all this work, we get this down to vertex form. Now, just to emphasize this point, if you were to take vertex form and just to multiply this all out, you would get back to the original standard form. But the reason we have it in vertex form is, of course, we could say some things very quickly, that the vertex of this function, the vertex, is located at -5, -8. If you were to graph this on an xy plane, that's precisely what you would see. So as always, thank you for watching. Keep working hard at these types of problems. They're not exactly easy, but you can certainly do it if you persevere. Thank you for watching.